Hi guys, in this video I'm going to talk about 7 most important topics in AI that everybody needs to know. I will go over what is the meaning of each of them and what does it mean for you and how we can start learning about them. So without further ado, let's jump right into it. Welcome everyone to your channel, AI Fun Fact for All. For those of you who are new to this channel, my name is Bedram. I have a PhD in computer science, and in this channel we talk about AI and machine learning and how we can use it in order to improve our efficiency. As you can see from my review, I have recently changed where I was living, and that was the reason that I hadn't made videos. But in this one, I'm going to talk about these 7 most important topics in AI, and the first one is gonna be Agentic AI. So in previous video, I've talked about the difference between the other type of workflow and Agentic AI, but in this one, I wanna basically show an illustrative of what an Agentic AI means compared to a pure chatbot. So when we talk about the basically Agentic AI, we are gonna talk about the different workflow and steps that it's gonna consist of. So the first step is basically the perceive step, where it basically try to get the information from the environment. After that, we have the reasoning step. In the reasoning step, it will try to provide reasoning or break down in the formal chain of thought in order to provide the response to you. And then after that, it's gonna act. Basically, that's the very important portion of React framework, that basically it tries to do some action for you rather than just provide some response for you. That can be as easy as calling an API. And then after that, it will observe. So whether it's going to be the result of API or the response that it gets, that's going to include the observe, and it basically close the loop and go to the perceive of the next step. So it can basically create a complete full workflow of this process, and that can kind of bring and break down a hard problem and make it easier for you. So that's why Agentic AI is the most important topic in 2025. On the second one, I want to talk about large reasoning models. So the difference between large language models and large reasoning models is the fact that these models are actually designed to solve complex problems. And we have, for example, for ChatGPT, a series of O3 models, but basically the whole idea of large reasoning models is the fact that they are purely designed to do test time compute in order to break down a process through their internal chain of thought. So I've also created a video about it that talk about the idea of using reinforcement learning to provide reasoning steps before achieving a task. That was the process that we saw also in the basic conventional O3 models, and the policy that it will provide will try to suggest the model in order to provide some reasoning that can be adequate to solve a very hard problem. So basically how it works is that it tries to break down the problem into different steps through its multimodal model. It tries to go over different steps and basically provide the best one, so it can basically use and provide the reasoning response during the test time. Now moving on to number 3, I'm going to talk about basically the vector databases. So the vector databases is also a very well-known idea that is used when we're going to talk about RAG, also another very well-known concept. But the idea of vector databases is the fact that we don't want to save the data purely in their basically binary format. We want to facilitate accessing them based on their meaning. So in this case, for example, for text or for images, that would be basically their contextual information, or for example their semantic meaning. Let's say we have a text or we have some image. If you want to save them in a conventional database, that would just save their pure basically binary format. And then if I'm gonna look for them, I either need to know some information about their names or basically some tag information. But basically I cannot query that database to give me some information that are related, for example, to some specific topic. For example, some texts that are related to for example, solving a math problem. I can definitely do that because I don't have any clue of what the information inside it gonna look like. So the vector database actually solved this problem by creating basically some embedding model, and the embedding model in here will try to basically convert the whatever information we have into some vector. So some vector of numbers, it can be saved, and then after that what I can do is that if I'm looking for some other object, I can basically compute the cosine similarity with this, and then I can see that whether this is close to it or not. So let's say as an example, I'm saving an image of, for example, some mountain, and then instead of saving pure, I save it in a vector database. So it basically create an embedding model of it. The idea of embedding is basically try to create a numeric representation of those, which is not the pure binary values, but rather it is the semantic meaning. If you want to think about it, it would be something like, for example, how the atmosphere gonna look like, or what are the edges in the images. So if you're familiar with the vision deep learning models, anything that happens in the deep layers can be considered as one of those steps. So basically any Z space information can be considered as that, and let's assume that it's gonna be some vector of images. And now if I'm looking to find some similar scenery information, such as, for example, a beach or something like that, then I can compute with the same model to compute the embedding, and then after that I can compute the similarity between these two, and then I can basically easily find whatever information that I have that are related in terms of meaning rather than the pure binary values. And now very close to number 3, we have number 4, which we actually talk about it. It is the RAG, or retrieval augmented generation. So how it works is that instead of having a prompt that is just purely talking to our LLM, we are going to basically make sure that we retrieve the relevant information into it and then provide the result into it. So what will happen is that the prompt will be connected to something called the retriever, and then the retriever will basically go to our embedding model that we talked about in the previous one, and then it will go and query our vector database. So then what will happen, the retriever will actually bring back the response that are related, and when it become related, that I'm gonna augment it to my prompt. So let's say I want to look for some specific information. Instead of some generic prompt, I can add some related information to that prompt and give the LLM and say that, okay, this is the context that I'm talking about. So there is a difference between prompt engineering and context engineering. I've also created a video on that. I will put the link at the end, so you can definitely watch it. Moving on to number 5, we have basically MCP server. So the concept of MCP server is basically another way to actually enrich and empower the LLMs. Now the LLM have some basically pure knowledge that are based on whatever data that they observe, and they are saved within the weights. But as the task become harder and harder, definitely that information alone is not enough. So that's where we need to have some information from outside. It can be through our internal resources via the vector databases and RAG, or it can be connected to some internal through the MCP. So I have created another video on MCP that talk about the differences between MCP and API. MCP will try to standardize the process of connecting LLM to outside information. So in here, let's say I have an LLM, and then I have some databases, I have some code, I have some email service, or I have some basically API such as weather information. And then if the user asks some question like what's the weather like right now in San Francisco, this is obviously an information that is not going to be saved inside the parameters of the model, because it doesn't know what time is it, and it's not very efficient to do that. So in that case, the LLM will actually try to call the API for the weather and then basically responds to that. But the process will be very ad hoc if you want to have multiple different API, and for that reason we're gonna create an intermediate position in here that is gonna act as our MCP server. That's basically how we expose our LLM to all of the different APIs, and this will take care of how we can do the authentication and other stuff on the backend with our third-party services, and how we can basically get the information. This basically means that our LLM doesn't need to be worried about how to basically create the results to be adequate and basically enough to be able to talk to the specific outside resources. In number 6, we have MOE, or mixture of experts. So this one is actually a little bit more on the complicated side. The process of MOE is again not very new concept, but it is getting a lot more attention as we are going towards some low latency and on-device response from LLM. And we have so many open source models that are trying to work towards this MOE. And the whole concept is that instead of having a fully connected network that at each time all of the, like for example, trillion parameters are active, which is a dense model, it is good, but it is sometimes overkill. We try to create several different experts, and these experts are spread out through the different depths. And as we are providing a question, then on each token level, we're gonna select a one or a few, for example, 8 number of experts to be fired, and then the rest are going to be basically untouched. So what will happen is that the effective number of experts that are intact at the time would be equal to the numbers that we assign, and those are going to be selected based on our gating mechanism. And this will help a lot, because if we have, like for example, a very large amount of experts, even though in theory we need to have location for all of them, but for each response I don't need to have them active at the same time. This will increasingly improve the latency and also make the system to be able to run in local computers. And the last but not least, I'm going to throw a big one, which is basically the ASI. So you may already have heard the concept of AGI, or artificial general intelligence. That basically means having an LLM that have the capability of human in any expert. So basically we don't have that kind of human, and that's why it is superior to human, but the capability that it has does not surpass the capability of human expert in each level. So it will just match the experts of human in each task and can provide every response. So that is something theoretical. We haven't reached it yet, but OpenAI and lots of other companies are actually moving towards that. But we have something called ASI, or artificial superintelligence. So the difference between ASI and AGI is that ASI actually will go beyond that. So it can basically provide the expertise and the intelligence beyond the human level. So theoretically, it can basically redesign and it can upgrade itself. And the reason is that it have the ability to actually improve and recognize its failures and try to basically recursively provide a better and better version of itself. So that's exciting, at the same time daunting, but let me know in the comment what do you guys think about ASI and how far we are to achieve it. And there you have it, guys. We went over 7 different important concepts that everybody needs to know on the AI that you might heard a lot in lots of different videos. So in this one, I try my best to actually give you a very brief understanding of what each term means, and I provide related videos for you so you can watch. If you enjoyed the video, make sure to like it. More importantly, subscribe to the channel. If you want to see another videos, I will suggest that you watch the AI Snap, that I'll talk about the approaches that you can use in order to improve your low quality AI content, and you can watch the Kimi K2 in here, which is basically another open source model that gives you the ability to understand how the mixture of experts actually works and what makes the open source model different from the closed ones that are only available with the big companies. Thanks for watching, and see you until the next one.